In this video we'll start to do questions which have no right angle. I would like to introduce you to my triangle solver, which you can download a copy of from my website or take a screenshot later on. As usual, I have got a bigger version for using with videos, and there it is. Now what's it for? It's there so it's easy to see the logic that you use when deciding the method for solving your triangle. If you see, the first thing, we start with all triangles, so we'd have a triangle, and then say it was a right angle triangle, you'd go down there, and then the decision would be, has it got an angle involved? If so, it's the SOHCAHTOA you've seen. No angle involved, then you get Pythagoras theorem. In the next couple of videos we're going to look at this next side here. So I'm going to start just by doing a couple of problems. If you have a look at the triangle up there and have a look, you'll see that it's got no right angle, so therefore we come down there, so it's no right angle. And then you look at the sides and you can see we've got each side with a number on it, so it's 21, 16 and 22. So that means all three sides are involved, and that means we come down here, which means that it's one of the versions of the cosine rule. The x is on an angle, so we're asked for the angle, therefore that is the one that we're going to use. I'm going to put my big one away and we'll bring the wee one in, which I'm just going to set up the top here. Right, so we're ready to start. So as usual, we draw a version of the triangle and do not mark the units in, just 21, 16, 22 and your x. Now it's not a right angle, so there's no hypotenuse, opposites and adjacents, so it's a different method of naming. And what we do is we start and call the one we're looking for, and the corners are capital letters, so that will be a capital letter A. So if that's a capital letter A, the side across from it is the small letter a, and that's the way we name them. To keep everybody's working the same, especially if you're a teacher and you're teaching this, make sure that you tell them this so you get the same working from everybody. Name it A, B, C clockwise on the corners. So A, B, C. So that means that this one there is C, opposite from C, and this one there is opposite from the B, so it's B. Now we said we were going to use that cosine rule, and if you notice the brackets are in red, make sure you use these brackets. You will get the formula in your exams, but they never put the brackets in. Make sure you put the brackets in immediately. So what we have is cos A equals, open brackets, b squared plus c squared minus a squared, close brackets, and then we have on the bottom we have open brackets 2bc, close brackets. All we do now is put in the numbers. The a is the x, so we go cos x equals, open the brackets, b is 22, 22 squared plus c is 21, 21 squared minus a, which is 16, so it's 16 squared, all over, open brackets, 2 times b, which is 22, times c, which is 21. Now, make sure your brackets on the bottom as well, because if the brackets are not there, it means you will get the wrong answer. So take your calculator and just type in the formula. So you open brackets, 22 squared plus 21 squared minus 16 squared, close the brackets. Now remember, you're going at the bottom line, so divide, open brackets, 2 times 22 times 21, close the brackets, equals, now the answer you get is 0.7240, etc. Always take three figures, although as usual we're going to keep the answer in the calculator, but we have cos x equals nothing, 0.724. So only one thing left, and that is the removing the cos. So remember, shift the cos. It's actually cos minus 1, so you go shift the cos, or second function cos. So we go shift cos, and you can just press equals because it'll take the answer in, and you can see to one decimal place our answer is 43.6. And that is our first example. Now we have our second example, and again start off, it's not a right angle triangle, so we're down here. Are all three sides involved? Well, we've got an 8.5, a 10.8, and the one we're looking for is the x, so that means that all three sides are involved. So we're down the all three sides, and this time we're asked for a side, so it's that one there, right? So as usual, straight into it, draw a similar diagram. Remember, don't mark in the corners as they are there, we're going to put our own in. 27 degrees, 8.5 and 10.8. The one we're looking for, the x, is on that side, so we'll write A on it, which means the capital A is the angle opposite, and start naming from there. Always name from the capital letters clockwise. So we've got B and C. So we're all set to go. That's our formula there. So we write out A squared equals B squared plus C squared minus 2 times B times C times cos A. Putting in our numbers. Oh, change that to your x. The A was the x, so it's x squared equals B squared, which is, oh, I hadn't named it. B's there, C's opposite the C. So we've got B is 8.5 squared plus C is 10.8 squared minus 2 times B, which is 8.5, times C, which is 10.8, times cos, and the angle was 27, remember to have it in brackets, and we're ready to calculate the x squared. So get your calculator, and we just go 8.5 squared plus 10.8 squared minus 2 times 8.5 times 10.8 times cos 27, close the bracket, calculator lets you off with it, and you get your answer, which is 25.30. Always keep an extra point, but they're an extra figure, but you don't really need it there. Now to find x, we staged before, you notice we didn't need to put any brackets there. If it's in one line, you just do it as it is. So now take square roots, you go square root and equals, and the square root of 25 gave you 5.03. Now the answer was in centimetres, so that's 5.03 centimetres, and that's all there is to it.